Hello everyone, my name is ARTH and welcome back to my channel Create Arts. If you haven't checked out my previous video, which is Orbis 1, please check it out. And if you have, check out my new video. This is about NLP. What is NLP? It's natural language processing, popular and very important AI domain. I won't get into the depths of it, but let me just cover it for you because my next project is based on it. So NLP is a broad field under AI which covers computer sciences and linguistics. It takes into account the natural language of humans. It detects the tone, the sentiment. It takes into account a large amount of data, which is the corpus. The corpus has different data features. They have labels and they hold importance for the model as well. Now, the corpus in text preprocessing is divided into tokens. Tokens are the smallest meaningful units of the data. This is very important. Every token should be meaningful. It is assigned a number, that's term frequency, inverse document frequency, and that number highlights the importance to the NLP model because we won't want any outliers, any anomalies in the data. We need important information. The crux out of a whole bunch of documents is the work for NLP, and we have an application for that. That is sentiment analysis. It is very common. You might have seen it. Businesses, companies use sentiment analysis to predict and to analyze the tone, the sentiment, the feelings behind a piece of text, and which is a review from the customer. So today I'm going to present my sentiment analysis, though it's not based on any customer ratings, but it is all about entertainment part. It's where you put the ratings for the movie. Let's go. So here is my project. Yes. So firstly, we would like to cover the basics from here, how to import and all. So this is Scikit-learn. We have written feature extraction, text, import, CountVectorizer. Now, what is CountVectorizer? It's a tool from Scikit-learn. It converts the text or the sentences into numerical vectors, just as I said before, using word counts. Now, before we move on, I would like to tell you one algorithm which is known as bag of words, which is used in NLP. So, bag of words algorithm returns the unique vocabulary of words and it returns the frequency in their documents, which is the number of times that word has appeared in a specific document and across the corpus. Now, the stop words, which are meaningless words, they occur a lot of times, but the value is zero. Now, there are extremely important words, which are rare words, where the frequency is very less, but they have appeared in a certain number of documents and they are very important and integral to the piece of text that we are referring to or the corpus. Now, here we have knife bias, import multinomial NB. So we'll get into the depths of it later. This is the reviews. This is the data. I love this movie. It was amazing. And then it is followed by our label, which is positive or negative. So it's a list of tuples. It's first element review text and second element label, positive or negative. Then we will initialize the vector. So basically it creates an instance of CountVectorizer. It will break the sentences into words known as tokens. It will build a unique vocabulary and it will count occurrences of each word. Now, here in text, comma, labels is equal to zip asterisk reviews. What is this? This converts all text into the text data type and labels into label data type. Now, by data type, I actually mean this is specific function of NLP model in Python. Now let's convert the labels into binary, which is binary labels, which is numbers 1 or 0. They represent the importance, but here I have kept it very simple for you guys. Then we are converting text into numerical vectors. So each word, each token is a vector. It's a numerical vector. So fit transform. Now you might be wondering what's this fit transform function? Fit transforms does two things. It learns all unique words, which is the vocabulary, and it converts each sentence into a word count vector. Now here we go. We convert it into the array. So features x dot to array. It means it converts the sparse matrix into a normal 2D array. Then each row refers to one review and each column one word from the vocabulary. Here we can see 1, comma 0, 0. So these are basically the numbers that are highlighting the importance of each token. Then this is the vocabulary. This is the feature matrix. Now, what is the naive Bayes thing? It's the classifier and it's good for text classification in simple terms. Text classification is also a part of NLP. It is also an application of NLP. Now here we are creating a model. When we say model is equal to multinomial NV, it means it is initializing the classifier. Now here we go training the model. Model.fit features, comma, binary labels, which is we are training the model using features input data and binary labels output data. And this is the new test data. These are the new unseen reviews to test the model. Now we have converted new text into vectors. We are using the same vocabulary. This is very important. It is converting new text into numerical format, and then we are predicting the sentiment. Model predicts +1, -0. And then we are printing the results. Now we are converting the predictions into labels. So they're readable for all of you and the user. And this is the final output. It prints each review with its predicted sentiment. Now here we go. Positive, negative. Let me see. A visual masterpiece with a gripping storyline and stellar performances. Then this is the worst sequel of this franchisee. I hate it. Very negative. Now 1, 0. A visual masterpiece with a gripping storyline and stellar performances is positive. This is the worst sequel of the franchisee. I hate it. It's negative. This was the final output example. So we just built a mini AI sentiment analyzer. It is converting text into numbers. It trains a model. It predicts emotions in new text. So thank you everyone. This was my project. I have uploaded the code on the Avashka community. You can refer to it. You can learn from it. You can tell me in the comments what I can improve further. So thank you guys and see you in the next video.